Today we are going to continue looking at solving quadratics by factoring. But as we look into more complex solving by factoring, we now have two pieces we're trying to keep straight. We have all of our factoring rules that we have to consider, and we have all of our rules for getting it factored, setting it equal to 0, and then solving those individual equations. Those can start to get pretty lengthy. So we want to make sure we are taking the best approach to factoring to help us do that as quickly as possible so the problem doesn't become any longer than it needs to. So while you can stick to all of the factoring rules like you already know, we're going to sort of run through an approach that might help eliminate some of the stress of doing things in a very lengthy process. Which means when we are solving a quadratic, okay, those same rules we talked about yesterday, okay, it has to be set equal to 0 before we start factoring. We know that to be true. None of that is changing, okay? But when we get to the point that we want to start factoring, the very first thing that we are going to try and look for is a GCF. Okay, it's not a requirement, but if we do that first, it's going to make our lives a little bit easier. So for example, we will ask ourselves, is there a GCF? If we say yes to that, so if we see something like 6x squared plus 42x plus 72, right? We'll ask ourselves, is there a GCF? And the answer to this question is yes. So if we say yes, we will factor out that GCF. Now, maybe you see the whole entire GCF at once of 6. Maybe you don't. Maybe you only see 2 and then you see 3, but just like we would normally factor out a GCF, we're going to divide that out. They do not all have the x, so we're just pulling out a 6, which will leave us with an x squared plus 7x plus 12. Can't take that any further, and so we would factor out that GCF. Now, if we're given something that says something like 5x squared minus 3x minus 8, right, when we ask ourselves, is there a GCF, and we look at the problem and we say, okay, is there something that will go into 5, 3, and 8? The answer is no, there's no GCF, and so we would just skip that step. Okay, and then we would move on to the next question. So the next question then says we're going to ask ourselves, how many terms does that polynomial expression have? So now when we look at it, we're going to go based off the number of terms that it has. So if we look at it and we see that there are 4 terms would be our situation where we want to factor by grouping. So we know factoring by grouping is our situation where we split it in half, right? And we want to pull out the GCF of each side, right? At this point, we have already assessed over this, so this portion shouldn't really be any additional work for us. Right, same thing over here, we pull out the GCF. And so we would say this factors into a 5y squared plus 2, and a 3y minus 4. If it has 3 terms, then we're checking to see, does A equal 1 or does A not equal 1? Right, if A does equal 1, we know we can use our trinomial shortcut where we're finding our, 1 and 24, 2 and 12, 3 and 8, 4 and 6, right? That's going to end up being our set. So we know we can factor this into a W plus 4 and a W plus 6. If A does not equal 1, right, we don't have a choice. We have to go the long route. We have to multiply A times C and then go all the way through, right? So we'd say 5 times negative 8 is negative 40. Making our set. And we're checking our signs. So we'd have a 5 and a negative 8. Again, at this point, this should not really be additional work. We should say we know how to do this. Factor out our GCF. When it starts with a negative, right, we factor out a negative. So we'll get a 5x minus 8 and an x plus 1. And if there are 2 terms, we want to check and see if there is a special case. Right, so we're checking to see if it's 2 terms, if it's subtraction, right? That was another catch, is that it had to be subtraction. and then that they were both perfect squares. So this is a special case. So a number times itself, that gives us 16 is 4. And we take half of the exponent. So this would go into an a squared minus 4 and an a squared plus 4. And then our final step would be to check and see if there are any special cases that we missed. Keeping in mind, it has to be two terms, it has to be subtraction, they have to be perfect squares. So for example, right, if we look at this up here, a squared minus 4 and a squared plus 4, a squared minus 4 is still a special case that we could factor, right? Because this is still two terms, they're both perfect squares, and so we would get an a plus 2 and an a minus 2. But a plus 4, we can't. It's not a special case because it's addition. So we can't go any further with that. Okay, so all of this together is basically review, but we're going to use that process to help us do this in a quicker manner when we are solving by factoring. Because if we look at this example right here, number 1, 3x squared minus 9x minus 54 equals 0. If we were to solve this by factoring for what we just already know, it's set equal to 0. If we were to just look at this problem, option 1 would be to say, I see a trinomial. A does not equal 1, so we need to take 3 times 54, which gives us 162. And already you're probably going, oh Lord, 162. So we do 1 and 162. And then we start making our list. 2 and 81, 6, 7, 8, 3 and 3. 54, right? We're just making our list. 4 doesn't work, 5 doesn't work, 6 should work. Gives us 27. Not there yet. I mean, right? We just get this big old long list. 9 and 18. So there's our set, right? We eventually get to 9 and 18. And we know we want this 18 to be negative. So we would have to rewrite this into 4 terms. So we'd have to say 3x squared plus 9x minus 18x minus 54, right? And then we would factor this by grouping. That's just how we factor trinomial when a is not 1. Has a GCF of negative 18. So we'd have to not only see that negative 18, some of us might have to divide multiple times. Okay, so this would factor into a 3x minus 18 and an x plus 3. And if that wasn't bad enough, right, we're not done yet because this is still something that's set equal to 0. And so now we would set each of these equal to 0. So now we'd say 3x minus 18 equals 0. And x plus 3 equals 0. So now we need to solve both of these. So we get an x equals a negative 3. Right, it hardly even fits in this space. And our other one is x equals 6. Okay, so all of that work for one problem. Now, if we take the approach that I just mentioned to you today, so I'm looking at this exact same problem, I want to show you the benefit of doing what we just talked about. So instead of just going, oh, this is just what I see first and this is the approach I'm going to take, we're going to ask ourselves, is there a GCF? So does 3x squared minus 9x minus 54 have a GCF? The answer to that question is yes. And so the first thing we're going to do is factor out a GCF of 3. Okay, and so that factors into a 3 times an x squared minus 3x minus 16. We are then going to focus on what we have left inside the parentheses. So we're going to focus right here on what we have left inside the parentheses, and we are going to count how many terms there are. Okay, we have 3 terms left inside of the parentheses, and it is a equals 1. So that is our trinomial shortcut. So I'm going to focus on this x squared minus 3x minus 16, and I'm going to factor this as a trinomial shortcut. Oh, this is an 18. Sorry, guys, this is an 18. Okay, so I'm going to factor this as a trinomial shortcut. Okay, so I'm taking my negative 18, 1 times negative 18. I'm just ignoring this 3 over here. 1 and 18, 2 and 9, 3 and 6, 4 and nothing, 5 and nothing. I'm going to check my signs. And I can use the shortcut. So this right here factors into an x plus 3 and an x minus 6. We're just still bringing this 3 down. Okay, and now we have this factored. We didn't have to do any of that rewriting and factoring by grouping. Now that we have it factored, now we can set those equal to 0. Well, this GCF of 3 is kind of irrelevant. 3 can't equal 0. It doesn't matter. So we're going to set x plus 3 equal to 0 and x minus 6 equal to 0. And even this is easier to solve. And we get the exact same answer, but with a lot less steps of factoring. So way less work to get that factored if we pull out the GCF first. Okay, so let's look at this next one. It's already set equal to 0, which is what we need. First question we're asking ourselves, is there a GCF? Yes, there is a GCF. The GCF is 3. Right, our second question that we're asking ourselves is how many terms there are. So again, we are focusing just inside the parentheses, and there are 2 terms. So 2 terms says we are going to check for a special case. This is a special case. Right, we should already know how to factor a special case, so that piece shouldn't be a surprise. So this will become an a plus 3 and an a minus 3. This is coming down out in front, and it still equals 0. Right, 3 can't equal 0, so that's irrelevant. We're only looking at our factors with our variables, so we'll say a plus 3 equals 0 and a minus 3 equals 0. These are nice and simple to solve, so we'll get a equals negative 3 and a equals positive 3. That's a very weird square. Okay, when we look at our next one, right, it has to be set equal to 0. This is currently not set equal to 0, so that's the first thing we need to do. My recommendation is that you always keep your a value positive. So even though it might be easier to just move the 2b squared, that's going to end up with b being negative, which is going to be a lot more work. So we want to move towards that 2b squared. So I'm going to move a positive 3b by subtracting 3b. And a positive 9 by subtracting 9. I'm going to move those over to the other side because whatever I do to one side, I have to do to the other. And I'm going to keep these in my trinomial form. A squared plus b squared, or ax squared plus bx plus c equals 0, which is what we want. Then we're going to ask ourselves, is there a GCF? The answer to that question is no, there's no GCF. So then we move on. There are 3 terms, right? This is going to be a trinomial that we have to do the long way. So 2 times negative 9 is a negative 18. Okay, this is going to be our set right here. We don't have a choice. This one we have to rewrite into 4 terms. And then we have to factor by grouping. But again, hopefully when we are stuck in this situation, hopefully we know how to factor pretty successfully. So if you're struggling with what I'm doing with this work here, you're going to want to go back and rewatch the videos over factoring by grouping. So we'll have b minus 3 times 2b plus 3. But we're not done yet because those still have to be set equal to 0, right? When we don't have that GCF, these get lengthy. So we'll say b minus 3 equals 0 and 2b plus 3 equals 0. And this is going to be a lot of work I'm going to squish in here, so I'm going to write it over here. One of these is going to be b equals 3. So we'll get our other one is b equals negative 3 over 2. Okay, our next one needs to be set equal to 0. It is currently not. We want to keep our a positive. So our number in front of our variable squared, we want to keep positive. So we are going to move this 80 towards it. We don't want to move the other way, so I'm going to move this positive 80 by subtracting 80. Whatever I do to one side, I have to do to the other. Now, if we look at this and we just start, if we don't look for that GCF first, we're taking 8 times 80, which is going to give us a really big number. And I don't think we want to be finding our factors of 640. So if we ask ourselves, is there a GCF? The answer to that question is yes, there is a GCF. It has a GCF of 8. So we can pull out that 8. Then we're going to ask ourselves how many terms there are where we are looking inside the parentheses, right? The 8 is irrelevant, so I'm looking here. This has 3 terms. And actually, yours is going to be correct on your paper, but mine is wrong. This is going to be a positive 80 on your paper. So this will be a positive 10. So we're going to list our factors of 10. Sorry, right? Yours on your paper is going to say a negative 80 up here at the top. This is my fault. So we'll undo a negative 80 by adding 80, which makes that a positive. I forgot to correct that on my paper, but it should be correct on yours. Okay, and so we'll be able to have sets of negative 2 and negative 5. So this will factor into a W minus 2, a W minus 5. We still have that GCF of 8 out in front, equals 0. So we're saying W minus 2 equals 0. And W minus 5 equals 0. So we'll get 2 answers. We'll get W equals 2, and we will get W equals 5. Then our very last problem, okay, the first thing we're going to do is ask ourselves, is there a GCF? And this might be a tough one, right? You might really have to look through these options, but this does have a GCF of 3. And if we pull out this GCF of 3, we will get a 49c squared minus 25. Right, so now we're here. And then we're going to look inside the parentheses, and how many terms does that have? It has 2. So if there are 2 terms, we want to check and see if we can factor this as a special case, which we can. So this will factor into a 7c plus 5 and a 7c minus 5. Again, that 3 equaling 0 doesn't matter, so we'll have 7c plus 5 equals 0. Now you could write the 0 on the other side. I just think most of us prefer the 0 here, so I did that same thing over there, right? I'm just writing it in what looks more like a common equation, and I'm going to solve both of these. So let's see, we'll get c equals a negative 5/7. And c equals a positive 5/7.